So what is the root of an equation? We'll try to understand this through an example. Let's say we have a 1-degree equation, x minus 1 equal to 0. Why are we calling it a 1-degree equation? Because this equation has the variable x and the maximum power on the variable x is 1. That is why this is a 1-degree equation. So we have to find the root of this 1-degree equation. Root of an equation is the value of the variable in that equation that satisfies this equation. So what is the root? Root of an equation is the value of variable in that equation that satisfies the equation. Okay, so if x minus 1 equal to 0 is the equation and we have to find its root, we will solve this equation since it's a very simple equation. When we solve it, it gives us x equal to 1. So x equal to 1 is the root of this equation, x minus 1 equal to 0. And how shall we verify that x equal to 1 is the root of the equation x minus 1 equal to 0? So when we plug x equal to 1 in the place of x in this equation, 1 minus 1 equal to 0, since both sides are same, 0 equal to 0, so we will say that yes, we have verified that x equal to 1 is the root of the equation x minus 1 equal to 0. So root of an equation is the value of the variable in that equation such that when you plug that value in the equation, both sides are same. Let's try another simple example. Let's say we want to find the root of this equation. Now, first of all, this equation is a 2-degree equation because the maximum power on variable here is 2. So this equation is going to have two roots, two solutions, because the maximum power on the variable is 2. Or you can think like this, that if the degree of an equation is 2, it will have two solutions or it will have two roots. If the degree of an equation is 3, then it will have 3 roots or it will have 3 solutions. Now back to this example, x square minus 1 equal to 0. It's a degree 2 equation, so it will have 2 roots. How do we find these 2 roots? Since it's again a very simple equation, to find the roots, we will solve this. X square equal to 1 and taking square root on both sides gives us x is equal to plus minus 1. So here 1 and minus 1 are two roots of the equation x square minus 1 equal to 0. And how shall we verify that 1 and minus 1 are two roots? So for 1, just to verify that it is the root of the equation x square minus 1 equal to 0, so we will plug 1 in the equation, 1 square minus 1 equal to 0, so it gives us 0 equal to 0. So yes, x equal to 1 is the root of an equation. Which equation? X square minus 1 equal to 0. The same way, let's verify that if minus 1 is the root of an equation, we will plug minus 1 in this equation. Minus 1 whole square minus 1 equal to 0 gives us 1 minus 1 equal to 0. 0 is equal to 0. So yes, x equal to minus 1 is also the root of an equation x square minus 1 equal to 0. So this is how we find the roots and verify And now let's look at a third example. Let's say we have to find the root of the equation x square minus 4x plus 4 equal to 0. Again, this is a degree 2 equation because the maximum power on the variable in this equation is 2. So we know that we can solve our degree 2 equation by using a quadratic formula or factorization or midterm breaking. So we just use factorization here. So we know that x square minus 4x plus 4 could be written as x minus 2 whole square. So we use this formula, a minus b whole square is equal to a square plus b square minus 2ab. So here in this equation, x minus 2 whole square, when we open this up, it gives us x square plus 2 square minus 2. A here is x and b here is 2. Gives us x square plus 4 minus 4x. So we have to find the roots of this equation. X minus 2 whole square is equal to 0. Taking square root on both sides, it gives us x minus 2 is equal to 0, gives us x is equal to 2. Since this equation x square minus 4x plus 4 equal to 0 was a 2-degree equation, and here we have found the roots, x is equal to 2. So we'll say that here we have a double root. It has two roots which are the same roots, 2 and 2. And now let's say if we want to verify if 2 is the root of this equation, so let's take x equal to 2 and plug it in the equation x square minus 4x plus 4 equal to 0. When we do that, in the place of x we put 2. So it gives us 8 minus 8 on left side, which gives us 0. 0 is same as 0. So x equal to 2 has satisfied this equation. Which equation? This one, x square minus 4x plus 4 equal to 0. So we will say that x is equal to 2 is the root of this equation x square minus 4x plus 4 equal to 0. Now let's try another example. This time again we have a quadratic equation x square minus x minus 6 equal to 0, and we have to find its roots. And how many roots shall this equation have? Since it's a degree 2 equation, or maximum power of the variable x in this equation is 2, so here we have 2 roots or 2 solutions. This time we are going to find the roots by using factorization. You could definitely find the root by using the quadratic formula. So x square minus x minus 6 could also be written as x square minus 3x plus 2x minus 6 equal to 0. So we are going to find the factors. So we take x common from the first two terms, and from the next two terms 2 is common. X minus 3 here is common, so we will take it out. We have x plus 2 equal to 0. So we have two factors. This equation could be written as x minus 3 is equal to 0 or x plus 2 equal to 0. This gives us x equal to 3 or x equal to minus 2. So for the equation x square minus x minus 6 equal to 0, we have two roots, 3 and minus 2. And when we check that if 3 is actually the root, so we plug in the place of x in this equation, x square minus x minus 6 equal to 0, and if both sides are same, we will say that x equal to 3 is the root. So let's plug it in here. 3 square minus 3 minus 6 gives us 9 minus 9 equal to 0. Both sides are satisfied. So yes, x equal to 3 is the root of the equation x square minus x minus 6 equal to 0. Now let's try if x equal to minus 2 is actually the root. This is just the verification because we know that x equal to minus 2 is the root. So x square minus 2 square minus x minus 6 equal to 0. So 4 plus 2 minus 6 equal to 0 gives us. So again, for x equal to minus 2, the equation is satisfied, 0 is equal to 0. So we will say that yes, x equal to minus 2 is the root of an equation x square minus x minus 6 equal to 0. So now please see this. We know the equation x square minus x minus 6 equal to 0 has two roots which are 3 and minus 2. Let's call this f of x. So we have f of x equal to 0. Where what is f of x? F of x is x square minus x minus 6. Now since 3 and minus 2 are roots of this equation f of x equal to 0, you will say that if 3 and minus 2 are the roots of this equation f of x equal to 0, then f of 3 must be 0. And why is it so? Because f of 3, hence this is your f, 3 square minus 3 minus 6, you will see that this is 9 minus 9, this is 0. And also minus 2 is the root of an equation, so f of minus 2 must also be 0. And why is it so? Because f of minus 2 will be, since this is your f, so minus 2 whole square minus minus 2 minus 6, which is 4 plus 2 minus 6 equal to 0. So the point here is 3 and minus 2 are the roots of the equation f of x equal to 0. Then we will write f of 3 equal to 0 and f of minus 2 equal to 0. And this is here we have verified it is so. But will f of 1 be 0? That's the question. It will not be 0 because 1 is not the root of which equation? X square minus x minus 6 equal to 0. Since this is f of x, so 1 is not the root of the equation f of x equal to 0. And we can double check that. F of 1 is equal to, the equation is x square minus x minus 6. So in the place of x we have 1, gives us 1 minus 1 minus 6 gives us minus 6, which is definitely not equal to 0. So you have to understand that, let's generalize this result. If a is some number is the root of an equation. Which equation? Any equation f of x equal to 0, then this implies f of that number a must be 0. Let's consider a very simple example. X square minus 4 equal to 0. Let's call this x square minus 4 as f of x. So we have f of x equal to x square minus 4. Or on the side we can write f of x equal to x square minus 4 equal to 0. That's the equation. So we know that what are the roots of this equation? It has two roots, plus minus 2. We can verify that by plugging 2 and minus 2 in this equation. Both sides are satisfied. So yes, plus 2 and minus 2 are the roots of this equation. Now what do you say? F of 2 will be equal to? It must be 0. You can check that. Here you can check that. F of x is x square minus 4. And when you plug f of 2, you get 4 minus 4, which is 0. What about f of minus 2? It must be 0. You can check that. F of minus 2 gives us 4 minus 4 equal to 0. And why f of 2 must be 0? Why f of minus 2 must be 0? Because 2 and minus 2 are the roots of this equation x square minus 4 equal to 0. So whenever a number is the root of an equation, when you plug in the equation f of x equal to 0, the equation must be satisfied. Let's plug f of 1. Even before I check it, I verified, I know that it should not be equal to 0. Why? Because this equation x square minus 4 has only two roots. So f of 1 must not be equal to 0 because 1 is not the root of an equation. I can verify that. So f of 1 square minus 4 gives us 1 minus 4 equal to minus 3, which is not equal to 0. And it was expected. F of 1 is not equal to 0 because 1 was not the root. The same way f of 3, I don't even need to check it. I will say that it will not be equal to 0. X square minus 4 equal to 0 has only two roots. So for those two roots, we will say f of 2 is equal to 0, f of minus 2 is equal to 0, but any number other than 2 and minus 2, they will not make f of x equal to 0 because they are not the roots. So again, if we have some equation, let's say x square minus 2x plus 7 equal to 0, and if we are calling it f of x, then if f of b equal to 0, we will say b is the root of an equation. Which equation? X square minus 2x plus 7 equal to 0, or f of x equal to 0, because we are calling this thing as f of x.